every type of volcanic activity beyond Earth, space is complicated. We make it simple. Earth doesn't have a monopoly on volcanoes. Some of the most violent, most active volcanic activity in the entire solar system isn't happening here at all. It's happening on a moon most people have never heard of, and on at least one world. The volcanoes don't erupt lava at all. Every category on this list is a real, confirmed, or strongly evidenced form of volcanic activity found somewhere else in the solar system, and no two of them work the same way or erupt the same material. We're going in order from the most violent to the coldest, strangest version of the phenomenon. Then we'll sort them a second way by what's actually powering each one. Because on this list, the exact same basic process, molten material forcing its way to a surface, comes from wildly different energy sources depending on the world. Io, the most volcanically active body in the solar system. We begin with the most extreme example anywhere in the solar system, a small moon of Jupiter that outperforms every volcanic world discussed on this list, including Earth, by an overwhelming margin. Io hosts hundreds of active volcanoes, some producing eruption plumes that shoot material up to 400 kilometers above the surface, dwarfing anything ever recorded on Earth. Here's the fact that should genuinely bother you. Io's volcanism isn't powered by leftover internal heat from its formation at all, the way most volcanic activity works. It's powered by tidal heating, an enormous continuous gravitational tug of war between Jupiter's colossal gravity and the smaller competing pulls of Io's neighboring moons, flexing and stretching Io's interior so violently and so continuously that the friction alone keeps a significant portion of its interior molten. Here's the part that lingers. Because this heating mechanism never stops, Io's surface is being constantly, continuously repaved by fresh volcanic material at a rate fast enough that the moon shows essentially no impact craters at all, despite billions of years of exposure to the same bombardment every other body in the solar system has experienced. The entire visible surface is, geologically speaking, brand new, over and over again, forever. Venus, a planet blanketed in relatively young volcanic rock. Here's the twist. This is the closest thing to Earth-style volcanism found anywhere else in the solar system, and also one of the most contested, actively debated cases on this entire list. Venus's surface is covered almost entirely in volcanic rock, with more volcanoes, over 1,600 major structures identified, than any other planet in the solar system, and radar mapping through its thick, opaque atmosphere has revealed lava flows that appear, based on surface weathering estimates, to be geologically quite young. Here's the fact that should genuinely bother you. For decades, whether Venus is still actively volcanic today, right now, remained a genuinely open question, since ground-based and orbital telescopes can't see through its dense cloud cover to directly watch for an eruption in progress. That changed only recently when scientists reanalyzing decades-old orbital radar images from the 9990s identified a specific volcanic vent that had visibly changed shape and grown between two separate observations taken months apart. The first strong direct evidence of an actual eruption in progress on Venus, rather than just old cooled lava. Here's the part that lingers. Venus's crushing atmospheric pressure and extreme surface heat, discussed elsewhere on this channel, mean any future volcanic eruption there would behave in ways genuinely different from an Earth eruption, with lava potentially flowing differently and volcanic gases interacting with an atmosphere already thick with sulfuric acid clouds. Mars, home to the largest volcano in the solar system. Here's the reframe. Mars isn't currently active the way Io or possibly Venus are, but it holds a different, equally dramatic record, the single largest known volcano anywhere in the solar system. Olympus Mons stands roughly 22 kilometers tall, nearly 3 times the height of Mount Everest measured from sea level, and spans a base wider than the entire state of Arizona, a scale that simply has no equivalent anywhere on Earth. Here's the fact that should genuinely bother you. The reason Olympus Mons could grow so enormous comes down to something Mars specifically lacks: plate tectonics. On Earth, the crust is constantly shifting, meaning a volcanic hotspot beneath the surface eventually drifts away from any single volcano, capping how large it can grow before the underlying crust moves on and starts building a new one elsewhere, which is exactly how the Hawaiian island chain formed as a single hotspot. Mars's crust doesn't move the same way, so the same stationary hotspot kept feeding the exact same volcano for potentially hundreds of millions of years, building it larger and larger, with no competing structure ever forming nearby. Here's the part that lingers. Some evidence suggests Martian volcanism may not be entirely extinct even now, with a small number of extremely young looking volcanic deposits and Marsquake data hinting that some magma may still exist beneath the surface in certain regions, meaning the largest volcano in the solar system might not be quite as permanently finished as it first appears. Enceladus and the cryovolcanoes of icy moons. Here's the pivot. This is where the category stops being about molten rock entirely and starts being about something that erupts liquid water instead. Cryovolcanism describes volcanic style eruptions on icy worlds, where the lava is actually water, ammonia, or other volatile compounds erupting from a subsurface source and immediately freezing or flash vaporizing on contact with a vacuum of space. Saturn's small moon Enceladus, discussed elsewhere on this channel, actively vents plumes of water vapor and ice particles from cracks near its south pole at roughly 200 kilograms per second, powerful enough to feed Saturn's entire outer E-ring with material. Here's the fact that should genuinely bother you. This eruption is powered by the exact same basic tidal heating mechanism driving Io's volcanism, just scaled down and acting on water ice instead of rock. Strong evidence that Enceladus harbors a liquid subsurface ocean beneath its icy crust, kept from freezing solid by the same gravitational flexing responsible for the visible plumes. Here's the part that lingers. NASA's Cassini spacecraft flew directly through one of these plumes and detected organic molecules and hints of hydrothermal activity on the ocean floor beneath, meaning Enceladus's cryovolcanoes may be actively venting some of the exact chemical signatures associated with the conditions life requires directly out into open space where a passing spacecraft can sample them without ever needing to drill through the ice at all. Triton and nitrogen geysers. Here's the fact that pushes cryovolcanism into its strangest, coldest known form. Neptune's large captured moon Triton, discussed elsewhere on this channel as a moon on a slow collision course with its planet, hosts active geysers that erupt nitrogen gas and dark, dust-like particles several kilometers into its extremely thin atmosphere, observed directly by Voyager 2 during its 1989 flyby. Here's the fact that should genuinely bother you. Unlike Io's or Enceladus's tidally driven volcanism, Triton's geysers appear to be powered largely by solar heating, acting on a thin layer of frozen nitrogen ice near the surface, where sunlight penetrates through a translucent surface layer, warms trapped nitrogen ice from beneath, and builds up enough pressure to erupt explosively upward through weak points in the crust. A genuinely different energy source from tidal flexing, despite producing a superficially similar geyser effect. Here's the part that lingers. Triton receives only a tiny fraction of the sunlight Earth does, this far from the sun, meaning the fact that solar heating alone is sufficient to power these eruptions says something genuinely strange about how little energy is actually required to trigger volcanic style activity on a world cold enough that nitrogen itself freezes solid. Ceres and mud volcanoes on a dwarf planet. Here's the fact that closes the gap between ice and rock with the strangest hybrid on this list. The dwarf planet Ceres, discussed elsewhere on this channel for its briny salt deposits hinting at recent water activity, hosts at least one confirmed cryovolcano, a mountain called Olympus Mons, believed to have formed from a slow eruption of extremely salty mud-like brine rather than pure water ice or molten rock. Here's the fact that should genuinely bother you. Unlike every other cryovolcanic body on this list, Ceres appears to have only one confirmed volcanic mountain of this kind, and models suggest other older cryovolcanoes on its surface may have gradually flattened and relaxed back into the surrounding terrain over time, their icy material slowly deforming and spreading out under its own weight, similar to how a glacier flows, rather than remaining as a permanent rigid peak the way rocky volcanoes on Earth or Mars do. Here's the part that lingers. This means Ceres's volcanic history may be significantly more extensive than what's currently visible on its surface, with the geological evidence of past eruptions quite literally melting back into the landscape over millions of years, erasing itself long before any spacecraft arrived to observe it directly. The moon's ancient volcanic past. Here's the fact that closes this list by bringing it back to the one other world humans have actually walked on. The dark patches visible on the moon's surface from Earth, the Maria, are enormous plains of solidified basaltic lava, evidence of volcanic activity that occurred mostly between 3 and 4 billion years ago, triggered largely by the same kind of impact events that created the large basins these lava flows eventually filled in. Here's the fact that should genuinely bother you. For decades, lunar volcanism was assumed to have completely ended roughly a billion years ago, but detailed analysis of small, unusually smooth volcanic features called irregular mare patches, combined with crater counting age estimates, has pushed the confirmed end date for lunar volcanic activity dramatically more recent to potentially within the last 100 million years, meaning the moon may have still had active volcanoes erupting during a period when dinosaurs were already walking on Earth. Here's the part that lingers. This discovery directly overturned a scientific assumption that had stood for decades, purely because later missions had higher resolution imaging capable of spotting features too small and too subtle for earlier lunar orbiters to ever have noticed at all. Proof that even a world humans have physically visited can still hide a fundamentally wrong assumption about its own basic history. Ancient volcanism on Mercury. Here's the fact that closes out the individual worlds with the smallest planet in the solar system, and one whose volcanic history was seriously underestimated for decades. Early flyby images of Mercury in the 1970s made the planet look essentially moon-like, dominated by impact craters with little obvious sign of past volcanic activity, but later, far more detailed orbital mapping by NASA's MESCAR spacecraft revealed extensive smooth volcanic plains and unusual, irregularly shaped depressions called hollows, believed to form when volatile compounds in the planet's crust vent and escape directly into space. Here's the fact that should genuinely bother you. Mercury's proximity to the sun and violent early bombardment history mean its volcanic record is unusually well preserved despite being billions of years old, since the planet lacks any atmosphere or weather capable of eroding these ancient features away the way wind and water have on Earth. Here's the part that lingers. Messenger's data suggests Mercury may have remained volcanically active far longer into its history than earlier models predicted, meaning even the smallest, most sun-scorched planet in the solar system had a genuinely dynamic geological past that simply wasn't visible until spacecraft finally looked closely enough to notice it. Let's sort these 8 again, a different way, not by how violent they are, but by what's actually powering each one. On the tidal heating end, Io and Enceladus, both driven by the same relentless gravitational flexing from a nearby massive planet, just acting on rock in one case and ice in the other. On the solar heating end, Triton, proving that even the faint sunlight reaching the outer solar system can trigger genuine eruptions under the right surface conditions. On the leftover internal heat end, Mars, Ceres, and the Moon, all powered primarily by residual heat trapped since formation, gradually cooling and shutting down over billions of years, rather than being continuously replenished by an outside force. And on the genuinely uncertain end, Venus, whose current activity level remains only partially confirmed, caught in the unusual position of definitely having erupted recently in geological terms, without astronomers yet being fully certain whether it's still erupting today. It's worth being clear, before we close, about exactly how much of this list was only confirmed because a spacecraft happened to fly past at the right moment. Io's extreme volcanism wasn't known until Voyager 1's 1979 flyby caught an active eruption plume by chance. Triton's geysers were caught only because Voyager 2 happened to image the right region during its single 1989 pass, and Venus's possible active eruption was only confirmed decades after the fact by scientists re-examining old data rather than through any live observation at all. Here's the fact that should genuinely bother you. This means the current list of confirmed volcanically active worlds is almost certainly incomplete, shaped as much by which spacecraft happen to be looking in the right place at the right time as by which worlds are actually active. Several icy moons that have never received a close, well-timed flyby remain genuine unknowns, simply waiting for the right mission to finally catch them in the act. Here's the last thing worth sitting with. Every world on this list is doing the same basic thing Earth's own volcanoes do, forcing material from deep inside a planet or moon up to the surface, releasing pressure that's been building somewhere no one can see. Some of them just happen to be erupting rock hot enough to glow, and some of them are erupting water cold enough to instantly freeze the moment it touches open space, and from far enough away, through a telescope, both look exactly what they are. A world, however small or cold, that still has something happening inside it. Not bad for stick figures on a rock.